Hello friends, this is Amal with AP. Welcome to the Python Fundamental series. This is the fourth video of this series. In the previous three videos, we have covered a lot of ground. We started with Python basics. We also studied about various IDE, Anaconda, etc. Okay, Anaconda. Let me correct the spelling. And we also discussed about Python syntax, semantics, and in the last video we discussed the Python basic and compound data types. And if you recall, in compound data types we discussed about lists, sets, tuples, and dicts. If you are joining us new over here, I highly recommend you to go ahead and watch the three previous videos. It will give you a very solid foundational background of what is going to come. Okay. In today's video, what we are going to discuss is we'll discuss something which is called control flow, and we'll also discuss functions. Okay. Now, what is control flow? We'll divide this topic into two parts. Control flow we'll discuss first, and then we'll go to functions. So what is control flow? This is the first question. Okay, control flow in a layman's term, you can assume that this is the nut bolt of any programming language. Okay, most of the program works because of the data types or the data structures and the control flow. Without control flow, the program will look like sequential set of instructions, okay, which are executed one by one. There is no there will not be any concept of looping or repetition. All these looping, repetition, special cases handling, all these are coming because of control flow. Okay, we'll see just in a minute that what is it. Okay, as part of control flow we are going to cover if, else, and a combination of if else, which is in Python Elif. We'll also cover for loop, while loop, and to end it with, we'll cover break, continue, and pass. We'll clearly understand all these concepts of control flow. Okay, we'll clearly understand that. If the time permits, and I hope it will also cover functions at the end, functions and lambdas. Okay, let's jump into our Jupyter notebook, where we'll start with if, else, and elif statement. Okay, now what is if and else? Okay, let's see. Let's go ahead and what is if, else, and elif? This is the question. Okay, we'll try to understand this with an example. Let's define a variable which is x is equal to 42. Okay, if we have to write a simple logic where we want to find whether x is equal to 0 or greater than 0 or less than 0, whether it's positive, negative, or 0, how we are going to write it? Based on what we know till now and based on the if statement, we can write something like if x is equal to 0 colon, you know that we have already discussed this, that in Python, the code block indentation is based on white spaces and colon. Okay, so we have to put a colon so that then my next code block will start. And if you notice, it has already given me a white space over here, 4, right? So this is the ID which is giving me 4 white spaces over here automatically. I will say that print x, and I'm going to pass a string, is 0. Okay, if I have to check, I will come out of that code block, and if I have to say that if x is greater than 0, if x is positive, let's say, what I will do, I'll again put a colon, new code block, this is for x greater than 0. I will do print x, I'll pass a string, is positive. Okay. If I have to find whether x is negative, what I will do is if x less than 0, I will do print x again is negative. So this is a very naive, simple way of finding it. Now let me run this. So 42 is positive. Of course, 42 is positive. Let me go ahead and put 0 over here. 0 is 0, which is this particular code block is getting executed over here. Let me put it like -2. -2 is negative because this particular code block is getting executed over here. Now, if you there are a few important things on basic things which we should understand, friends, over here. One is a code block starts with a colon. There are white spaces. This is the basic Python syntax. The code block indentation is not based on parentheses, it's based on white spaces. That's the first thing. The second thing, if statement is always followed by a Boolean logic. We have already discussed this Boolean data type over here, which is true or false. So this statement will either get executed into a Boolean true or false. So if has to be, if this statement is true, execute this. If this statement is not true, don't execute this. This is how it works. Okay. Now this is a naive implementation and it is working fine. But can we do better? Of course we can do better. Okay, so let me just copy this code and see how we can make use of it into a better code, and why it will be better is also we'll try to understand. Okay, so now if I will leave this equality part, what I will do over here is I will put a else loop over here. Okay, and I will indent my code. Again, I will put a else over here and I will indent my code over here. I'll remove this part. Let me quickly remove, and for the indentation, what I will do is I will go up. Okay, I think now the code looks good. Okay, let me see if this works first. Okay, yeah. So now what I'm doing is, difference between this code and this code is that the first is if a statement, the next is else a statement. Inside this else, there is a nested if and nested else. Okay, so my first code block is going to execute and check whether x is 0 or not. Only if x is not 0, in this case x was negative, this else statement is going to get executed. In else, it will go and check for this particular Boolean logic, x is greater than 0 or not. If it is not, it will go and execute this else statement. So this is how the if and else works at a fundamental level. And if you notice, this is much more easily readable also, because this is if else, and inside else it is if else. So this is more readability also. And from the computing standpoint also, if you notice, friends, here all the three if statements has to be executed. But let's say if I have put 0, okay, and execute this, only this particular portion is executed. The code will not execute in else because this is already true. Once this becomes true, else will not get executed. Okay, so from the computing standpoint also, the second code is far better than the first one. In the first one, even if this is true, all the subsequent code blocks will get executed. Okay, now this is what it is. Now let's see what is, this is if else, what is if elif. Okay, so again, can we do better? Of course we can do better. Let me copy this code over here and paste it. Okay, now what I will do is, instead of else, I will put elif. Okay, and I will use this particular x greater than 0, and I will remove this particular line from here. Let me just indent it, and what I will do is I will put this over here and one more indentation. Let me just quickly do it. Okay, so let me try to execute this first. X is 0, working fine. X is 2, x is positive, x is -2, x is negative. Now what has, friends, let's see what has changed between this and this. Okay, what I have done essentially is I have compressed or compacted your else if statement into an elif statement. Okay, that's all I have done over here. So this is a more compact and further easily readable format. So Python stresses a lot on readability. This is why it is. So this elif keyword or elif um, keyword which you see over here, it is compacting your else and if statement. Okay. Now, before we move on, one last time I want to tell you that pay good attention to this colon and this preceding white spaces. All the indentation or the code block indentation in Python works on colon and the white spaces. As a logic, as a tradition, we are putting 4 white spaces and not tab over here, right? So this is the common practice. Python doesn't mandate that, but we follow that as a practice, as a good practice. Okay. Now let's move on to, so we now, friends, we know that what is if, else, and elif statements. Now let's see what is, let me mark that as a code, as a markdown cell, and we'll see that, okay, what is for loops. Okay, let's go and talk about for loops. So loops in Python or in any programming language are a way to repeatedly execute a piece of code. Okay, so if there is a piece of code which has to be go in repetition, we have to use some sort of loop, and there are common 2 constructs of loop, for and while. Okay, we'll discuss both of them. So for example, let's say over here, if I have to write like for I in 1, 2, 3, 4, 5. Okay, I will close this. I will put a colon, indentation block, print I. Okay, now what it is going to print. And I hope you can understand the beauty of Python and with respect to any other programming language. What it is saying is for I, for any variable I, which is in 1, 2, 3, 4, 5. Now by now you know this is a compound object type which is list. So we are saying that iterate I over this particular list one by one and print. That's all it is saying, right? So we do not have to increment anything. It is automatically going from first to second to third to fourth to fifth element. Okay, and it is printing. So if we notice the simplicity of the for loop, we specify the variable we want to use. Okay, what is the variable? The variable is I. The sequence we want to loop over. So this is particular a sequence. A list is a sequence of numbers. So we have to provide us a sequence, and we'll talk about it, that what are the valid sequence types which can be passed in a for loop. Okay, and we use the in operator. We use this keyword which is in operator. So for I in 1, 2, 3, 4, 5, I takes the position of first, second, third, fourth, fifth element, and it is going inside the code block and it is printing. Okay, it is very intuitive and readable. Okay, now another concept is of Python iterators. Okay, now let me do a markdown over here. It is called iterators. And this whole concept of for loop or the repetition is based on iterators. So we will go ahead and understand this. What are iterators? Iterators are nothing but a data type which store some value and can be iterated over. Okay. Now, what is iterated over? That it can be sequentially fetched. Those data types are iterator data types. In more technical terms, if I have to say, then if that particular data types implement an iter method, okay, then those are iterators, and we'll just discuss in details that what are the iter methods. Okay, so in a layman's terms, if you have to understand that what is iterator, it's a sequence which can be iterated over, which can be passed over. Okay, so what are the common type of iterators? The common type of iterators are your lists, your tuples, your dict, set, range, Range is also an iterator type, and string. There are a few more, but these are the common ones. Okay, so as long as, friends, you are passing one of these data types over here, you can pass, instead of a list which I am passing, you can pass a tuple or a dict or a set or a range or a string. I will be capable of iterating it over and doing and performing the code block logic. Okay, so I hope the basic concept of iterator is understood. Okay, now let's see the examples. Okay, so I'm saying that for I in range 10. Okay, now range is a particular data type which is of sequence type. Okay, so range means that it will print 0 to 10 number. So when I specify range 10, that means start is 0, ending is 10, not including, sorry, I didn't do the print. Okay, let me print I. Okay, so it is starting from 0, not including 10, print the first 10. So 0, 1 to 9. Okay, we are printing that number. Okay, now similarly, if I have to do a, let's say, list we have already seen, so we'll go ahead with and do, let's say, tuples. Okay, so I will define my tuples, and if the friends, as you know, that it is defined by small parenthesis in the, if you watch the last video, I'm doing, and again I'm copying this and I'm checking. Now my iterated object or the sequence data type is my tuple, right? So what I'm doing again, my tuple I'm defining, I'm initializing as 1, 2, 3, 4, and for I in my tuple, now tuple is 1, 2, 3, 4, I'm trying to print it. Okay, let's see, it printed 1, 2, 3, 4. Similarly, if I have to do over, let's say, set, my set, and now if, friends, if you recall, the sets are defined by curly braces, they are unordered sequence of numbers. Okay, so over here I will just copy this and I will replace it with this and run. Okay, so if you see my set, again it is able to, this for loop is able to iterate over my set, which is again a sequence iterable object. Okay, now let's see in case of dicts. So dicts, if you are, let me define a my dict. Okay, my dict, if you notice that it is key value pair, if you recall from my last video, it is key value pair. So let's define, so I'm saying A colon 1, B colon 2, C colon 3. Okay, let's keep it this way. So dict, to recap, it is a key value pair. This is my key, this is the value, separated by a colon. Okay, separated by a colon. Each individual element, this is the first element, each individual element are separated by comma. Okay, now the rest of the code I will do from here. I will paste it here and I will replace my iterator object on which it is iterating with my dict. Okay, let's see. Okay, so it is going to do that. Now it is printing only the key over here, if you notice, right? By default it is printing only the key. If you have to print both the key and values, you have to use another method, mydict.items. It will give you key and value both. So for I, let me I, and let me define another one is, let's say, I'll say it key value itself. Okay, let's say key value, and I will print key and I will print value. Okay, so my dict.items iterable object gives two output, key and value. I'm iterating it over. Okay, so A and 1, B and 2, C and 3, and I'm going to print it. Okay, so if you say A1, B2, C3, it is going to print. Okay, so my friends, by now you understand that what is iterable objects, which are dictionary, tuples, list, strings, range. Those are the iterable objects. But what is this iter method which I was talking about? Okay, and why only these data types are iterable? These are the two key questions. One is why only these data types are iterable, and what about this iter object. So I was saying that if that particular data type or object has an iter method associated with it, those type of data types can be iterable and we can pass it into a for loop. Okay. Now what is iter method? Let's see. So let's define my set is already defined over here. Okay, my set. So I'll copy my set over here. Okay, so my set is a set variable which has 1 2 3 4. Now my set is also a iterable data type, so it exposes a function which is called iter. Okay, and when I pass my set inside iter, okay, and I put that into my iter. Okay, okay, now when I call another method which is next on my iter object, so I have defined a new object which is coming out of iter method running on my set. If I do a next, what is going to happen? Let's see. It is next means it is giving me the next object or the next element, next element in the my iter object. So this iter method has made my set into an iterable object, and when I am putting next on top of it or calling the next method, it is fetching me 1. Okay, now let me run this code block again. If I run this code cell again, it is fetching me the next element. If I run next time, it is fetching me the next element, which is 3. Now by now you would have guessed, if I run it one more time, it will fetch me 4th element. Now it has reached to the end. What will happen? Let's see. It will throw an exception. Okay, so it will throw an exception that, okay, I should stop iterating because it has reached to the end. Okay, so this iter method makes this object or data type, which is a set type, into an iterable object. Okay, that is one thing. This is the iter method. Second, why only these type of data types, list, tuples, range, sets, decks, string, only these are iterable? So let's see that what is so special about it. For this, what we'll do, we'll try to first understand a small example. Okay, let's see. So there is a dir method. Okay, what it does, it gives you all the default as well as methods, the default and the user methods which is defined for a particular data type. Okay, let's see if I do a dir on list, what it will give you. So it will give you very these funny looking, which are double score, add, underscore, and preceding and following with a double score. But if you go towards end, you will notice that these are also the methods which can be invoked through a dot operator. If you recall, then this is the something which we always used to do through dot operator. Like for my set, if you see, if I do a dot operator and press a tab, these are the things which are exposed, right? Okay, so these are the methods which are callable and exposed to this particular data type, which is my set. Okay, now this doesn't show you all these funny looking functions or methods, right, which starts with a double underscore and ends with a double underscore. These double underscore as a short form, commonly these type of functions are called dunder functions. What it is called? Dunder. Now dunder is just an acronym of double underscore. Okay, so D from the first and under from the, so it is called dunder. So double underscore is represented as dunder. Some people also called it magic methods. So these are methods which are associated with a particular data type. In this particular case, we are seeing with the list, but these are not exposed to user for usage. What it is being used for? It is internally being used by Python for its data manipulation. Okay, whenever it does some activity, it will go ahead and use it. Okay, now let's see. When I was saying that iter method has to be available for that particular data type, if you notice over here, this is the one iter method, right, which is in the class list. Okay, or in the data type object type list, there is an iter method which is available. That means my list can be an iterable object. Okay, this is one way of checking. Let me see int. I told you that int doesn't have an int is not iterable. If you see, there is an absence of, there is no iter method over here, right? There is no iter magic method or dunder method which is available over here. Hence, int is not an iterable object, or iter method is not available for int. Okay. Now, if you want, it is not important actually that you need to know the details of what are these magic methods. But if in case you are interested, let me just take 30 seconds and try to talk about that what these methods are. Okay, with an example, which will make it very, very clear. Let me see x is equal to 2. Okay, it's an int. I did that x is x plus x is equal to, okay, or let me do just the add thing, x plus 5. Okay, I got a result at 7. No problem. I am defining y is equal to, and since Python is a dynamically typed language, I am not starting with anything. I am saying ml with ap. Okay, I am defining it as a string. Okay, now when I do y plus, let's say I'm doing hello. Okay, what it will print? It will print ml with ap hello. So somewhere Python interpreter knows that if I'm doing a plus on an integer, I should add. But if I'm saying the same operator plus on a string type object, it should concatenate, right? Clear? Let me repeat one more time. So if you notice, I'm supplying the same operator, which is plus, right? In both the cases. But in first case, it is adding. It is doing an arithmetic add. In the second case, what it is doing is it is doing a concatenation. Now, somewhere Python interpreter is intelligent to know that in this case I have to concatenate and in this case I have to add. Okay, and the way it figure out is through these dunder methods or the magic methods. Okay, now if you have to do a dir of, let's say, int, okay, if you notice there is an add dunder methods also, okay, which is available over here. Okay, so when, now how we can use, we shouldn't be using this, but let's say if to showcase this example, what we can do is x dot, and we are doing a dot operator, we are adding underscore underscore add underscore underscore and passing the variable 5. This is same as doing x plus 5. This is same as doing x plus 5. Okay, so when I did x plus 5 is 7. If I have to do this over here, this is also 7. When we write x plus 5 internally, what Python is doing is this. Okay, it is knowing that this is an integer, it will go ahead and find this particular method of add which is there, and it will do that. Okay, I need to do an addition, arithmetic addition. In case of a string straw type, there is also an add method. Okay, there is also an add magic method which is exposed, right? But what it will do, let's see, it was y, right? My y was ml with ap. So what I will do is y dot underscore underscore add underscore underscore, and I was passing a hello, right? Now what happened is, see, ml with ap space hello, right? So in this particular case, which add is getting invoked? This particular add, and then not the add method which is associated with a int type data type, right? So this is the difference how magic methods are internally used by Python to do all these operations. Okay, so I hope this thing is very, very clear. If you have any doubt, please put something in the comment section. I will try to explain with a response over there. Okay. Okay, now let's move on. I think we discussed enough of for loop. Let's go to while loop. Okay, so let me do a markdown and while loops. So for was the one type of the loop, the while is another type of loop. This also does what is that, an iteration when a condition is met. Okay, let's see it with an example. So let's take a simple example of I is equal to 0 while I less than 10, and I'm starting again. If you see, it is very clear, right? I'm doing a Boolean operation like how I was doing in if and else. So while this is true, while this is true, what it's going to execute, it is going to say print I. Very simple, okay? And I'm going to do I is equal to I plus 1. I'm incrementing it, okay? So you guys, you can guess that what it is going to do, right? I'm starting with 0, I'm incrementing by 1, I'm printing, and printing till when? Till I is less than 10, so till 9, okay? So I'm printing till 9 over here. Once I becomes equal to or greater than 10, it will not execute. This whole Boolean logic will become false. It will only execute till this Boolean logic is true, okay? So for 0, 0 is less than 10, it will be executed as true. While is true, this particular code block will get executed. Once it becomes similarly till 9, it will be 9 is less than 10, true, it will get executed. When 10 less than 10, no, 10 is not less than 10, 10 it will become false, it will not get executed. This is the simple example of while loop, okay? And this is how the while loops works essentially. Now let's talk about your three things which are also equally important, okay? Break, continue, and pass, okay? Now what are these? Break, continue, and pass, okay? So these are two useful statements that can be used within loops, for or while loop, to fine-tune our program logic, okay? What the break statement will do? The break statement breaks out of the loop entirely. If I'm running a for or a while loop, it has, if I put a break statement over there, it will completely come out of the loop itself. What will continue do? Continue will stop that particular iteration. It will not execute rest of the code block, and it will go to the next iteration. So there is a difference. Break completely comes out of the for or while loop, okay? Completely comes out of the loop. Continue comes out only of that particular iteration and not of the entire loop, okay? Of the current iteration, and it will move on to next iteration. Pass is a little different. Pass is like a placeholder that, hey, do nothing, just ignore me and pass on. It is mainly used because sometime, and we'll see in an example that sometime syntactically it is much better that we should put a pass comment somewhere, okay? We'll just see in a minute. So let's see this break, continue, and pass with some examples to make it better, okay? For n in range 20, let's say, and I'll put a colon, next code block. If n modulo 2 is equal to 0, okay, then continue, print n, okay? This is the code logic I have written. Let's see what it is doing. So the first, we already know that how this particular piece of code works. This is the n, it is an iterable object. It will go from, range is from 0 to 19, it will do, because range 20, so 0 to 19. From 0 to 19, n is going to iterate over it. It will go next. It will, what it will do is n modulo 2, n modulo 2. So n divided by 2, and whatever the remainder, if the remainder is equal to 0, right, then it will go and pass over here. Otherwise, if n modulo 2 is equal to 0, that means that number n at that time is a even number. If it's an even number, it will do continue. Continue means it will come out of the present iteration and it will go to the next iteration. The n will get next value from this iterator object and continue, okay? If this condition is false, then it should go ahead and print n. Now guys, think for a moment and tell me that what it is going to print, okay? It is going to print all the odd numbers. And why it is happening? See, for n, let's say the n is 0. When n is 0, okay, n is 0. So the first element is n modulo 2 is equal to 0. That is true. What it will do, it will go inside the loop, it will continue, it will pass this particular iteration, it will go to 1. Now 1. 1 modulo 2, yeah, that is not, this condition will not state true. Okay, what it will do, it will not go inside this, it will go over here and print 1. Let's say 3, n is 3. 3 modulo 2 becomes 1, right? It is not equal to 0. Again, this becomes false. It will not go into continue block. It will go over here, print, and it will print. Let's say if it becomes 4, an even number. 4 modulo 2 is 0. 4 is an even number. It's modulus with 2. The remainder is 0, right? This becomes true. If this becomes true, it will go inside the continue. What continue will do? Don't execute rest of the code. Go at the top and pick the next iterable, next item. Okay. So it will not print. That's why it is not printing any even number. It is only printing your odd numbers. Clear? This is the example of what a continue will do. Okay. Now let's see what a break can do. Okay. We'll see with another example. A is equal to 0, a max. Let me define two integers, 100. I'm doing while true, a is equal to a plus 5. If a greater than a max, break. Otherwise, print a. Now, okay, I showed you the code, but let's see what this code is going to do. This is the break statement I am putting. I'm defining two variables over here. A is equal to 0 and a max is equal to 100. What did I say that break will do? The break comes entirely out of the loop, for or while loop. So wherever this break condition met and where the break will get executed, if this condition gets met, if this condition get met, that's the end of the while loop and it will come out. Okay. Till the time this condition is not met, this break will not get executed. What will get executed instead? Print a after that. So this condition is false, break will not work, print a will work, right? So what it is doing, let's see. Another important thing, friends, over here is true. So I'm not specifying that, I'm saying that while true. So this can work if I'm not putting a break statement inside this. This will go into an infinite loop because this is explicitly saying I'm not putting a logic like this over here, right? A Boolean logic. I'm explicitly saying it is true. So it will always remain true. This while will always get executed unless you have a break. So whenever you are doing while true type of statement, ensure that, otherwise it will go into an infinite loop. Ensure that you have break logic somewhere put in between. Okay. Now let's see what the code is doing. While true, okay, it is always true, always go in. A is equal to a plus 5. My first iteration, a was 0. Next iteration, a becomes 5. Okay, because I'm adding 5. If a is greater than a max is 100. If my a, which is currently 5, becomes greater than a5, 5 greater than a5, false. It will not go inside the break logic. It will print instead a. So that's why it printed 5. Next time, next iteration. This is 5. 5 plus 5 becomes 10. Now my a becomes 10. Is 10 greater than 100? No. It will still not execute this break statement and it will print a. Similarly, it will go till 100 over here. Okay. Now, when 100, then the next time it will come, the next loop, it will become 100 plus 105. It will become 105. 105 greater than mx, this will become true, right? 105 is obviously greater than 100. Go inside the break loop, go inside this particular code block and run break. Once the break runs, this while thing is terminated. My code comes out of the while loop. Okay, that's why it is printing all the multiples of 5 till 100. This is what this code is doing, and I hope you understand what is the break logic. In simple terms, what continue will do, again to repeat, continue will only come out of that particular iteration. Okay, and it will move on to the next iteration. It will not execute rest of the block of the code. Okay, instead what break will do, break will completely come out of the loop itself. Okay, clear? Okay, now let's see the last thing, okay, which is a pass. Okay, so for pass, let me, for n in range 20, again I'm using range, and if n modulo 3 is equal to 1, okay, pass. If n modulo 3 is equal to 2, I'm writing another pass. If n modulo 3 is equal to 0, I'm writing print n. Okay, now let's see what this code is going to do. Okay, so one thing is sure that, okay, this is going to execute from n range 0 to 19. That we already know, right? It will go inside this particular code block, okay, which is for the for loop. The first if statement says, and if a statement works on the Boolean logic, the first will say that, hey, if this modulo 3 is equal to 1, pass. What pass is doing, pass will do is it will do nothing. It will just pass on to the next code. It is literally doing nothing. It is just a placeholder. Okay, I do not know what logic I have to code when n modulo 3 is equal to 1. So I'm putting a placeholder over here. I will come and do the logic some other day. That's what it is doing. In case of n modulo 3 is equal to 0, what I am doing, I am printing 0. So this will print all the multiples of 3 till 20. Okay, so if you see the multiples of 3 till 20, because only print is over here. When the modulo is 1 or 2, I'm not doing anything, I'm just passing. So unlike continue or something, it is not skipping the rest of the code and going. What it is doing is, okay, just treat me as a null statement, as some statement which is of no consequence, no relevance, and move on to the next thing. This is a placeholder, typically used for the placeholder by developers, that when they do not want to code the logic immediately, that what happens in a particular statement, and put it on the last. Okay, now one will say that, hey, why even put that? Why can't we ignore? Let's see. If I have to ignore, and I commented it, right? Now n modulo 3 is equal to nothing is mentioned over here. Indentation error, expected an indented block. So this thing was expecting something over here because I have put an indentation, right? And there is nothing inside that. It will throw an syntax error, right? Indentation error. So to avoid that also we use pass. Okay. So this is the logic behind why we use pass. Okay. So this is the placeholder for future code. Do nothing and proceed further. That's all it is doing. Okay. Okay, so now this was all about control flow. What all we discussed? We started with for loop, if statements, else statement, elif statements. Okay, we also discussed about iterators. Okay, and why iterators work. We also discussed about the dunder functions or the magic functions, right? We also discussed about your while loops and for loops, okay, and how while and for loops work. We also discuss at the end break, continue, and pass. Okay, friends, this brings us to the end of today's session. I think we are already 40 minutes or 30 minutes done. I will try to park it over here, and in the next session I'm going to talk about functions and lambdas and what they are. Till then, if you have any question or comments to share, please put it in the comment box and I will try to answer. Again, if you like this type of content, please share it with your friends. That will mean a world to me. And I will see you all in the next video. So this is ML with AP signing off.